When people hear about a train with no wheels, they often assume it's futuristic, something experimental, unfinished, or still decades away. But the truth is more surprising. The fastest train on Earth already exists, and people are riding it today. It doesn't roll on tracks. It doesn't use wheels. It floats. This is the story of the Maglev train, magnetic levitation technology that has quietly turned science fiction into reality. Traditional trains depend on steel wheels rolling over steel rails. That design has served humanity for nearly 2 centuries, but it comes with a hard physical limit: friction. No matter how powerful the engine, wheels grinding against rails eventually cap speed, increase wear, and generate vibration and noise. Maglev trains eliminate that problem entirely. Maglev is short for magnetic levitation. Instead of wheels, powerful electromagnets lift the train slightly above the track, just a few centimeters, but enough to remove physical contact. Once airborne, the train is stabilized and pulled forward by changing magnetic fields embedded along the guideway. The track doesn't just guide the train, it propels it. With almost no friction, Maglev trains can reach extraordinary speeds while remaining smooth and quiet. At high velocity, air resistance becomes the only real limitation. This isn't theory. In China, a commercial Maglev line has been operating for years between Shanghai and Pudong International Airport. It regularly reaches speeds of around 430 kilometers per hour, making it one of the fastest passenger trains in daily service anywhere in the world. Thousands of passengers ride it, not as an experiment, but as normal public transport. In Japan, Maglev technology has been refined for decades. Japanese engineers have pushed the limits of what's possible, achieving test speeds of over 600 kilometers per hour. More importantly, Japan is now building the Chūō Shinkansen, a Maglev line that will connect Tokyo and Nagoya, with plans to extend to Osaka. When completed, it will make ultra-high-speed Maglev part of everyday inner-city travel. So if Maglev trains are real, fast, and already running, a natural question follows. Why aren't they everywhere? The answer isn't physics, it's economics. Maglev systems require entirely new infrastructure. Unlike conventional high-speed rail, Maglev tracks are not compatible with existing rail lines. You can't upgrade old tracks, you have to build new guideways from scratch. That means massive upfront costs, long construction timelines, and political risk. In many cases, Maglev projects cost 2 to 3 times more than traditional high-speed rail. Governments often choose proven rail technology because it's cheaper, easier to integrate, and less controversial. There's also energy use to consider. While Maglev trains avoid friction, they consume significant power at very high speeds due to air resistance. Operating them efficiently requires careful planning and strong demand. Yet despite these challenges, Maglev keeps returning to the conversation. China continues researching next-generation Maglev systems. Japan remains fully committed to its Maglev future. Engineers around the world are exploring combinations of Maglev and vacuum tunnels that could push ground transportation close to aircraft speeds. Maglev represents more than just a faster train. It represents a different way of thinking about engineering. Instead of improving wheels, engineers removed wheels entirely. Instead of fighting friction, they eliminated it. That's why Maglev feels so radical. It shows that many limits we accept aren't to laws of nature. They redesign choices. And when those choices change, entire industries can be reimagined. Will Maglev replace traditional rail everywhere? Probably not. But in corridors where speed, capacity, and long-term performance matter more than cost, Maglev may define the future of transportation. And the most important thing to remember is this: the future isn't waiting. It's already running quietly, smoothly, and without wheels. If you enjoyed this deep dive into futuristic transportation, like the video, subscribe for more tech documentaries, share it with someone who loves trains or engineering, and comment below, would you ride the fastest train on Earth? Thanks for watching.